I welcome you again for this NPTEL course on earthquake resistant design of foundations. And as discussed in the first lecture, that during this course you have the 5 modules. One is introduction, shallow foundation, pile foundations, well foundations, and finally soil resistant introduction for deep foundation. Today we are on the third, that is the middle of that is on pile foundations. And pile foundations are very important for earthquake resistant design of foundations. Actually, if you recall that during the first lecture where we discuss about general requirements of the foundation in introduction, we have discussed that as far as possible the engineer should try to with the shallow foundations because they are more economical. But if shallow foundation is not adequate, particularly during lateral loads or earthquake load, then we do not have any choice except to go for deep foundations. And the pile foundation and deep foundations falls under this category. So, what you have here, so what module 3 we are going to talk about pile foundations. Let us have what we are going to cover during the pile foundations. These are the topics. First one, we are going to talk only for static vertical loads, that means without any lateral load or earthquake load. This will be kind of a review which is typically done in undergraduate level, because let us first review when the piles are used and how we can obtain the pile load carrying capacity for the vertical loads. And once we discuss piles for static vertical load, then we are going to talk about lateral load on piles, which is very important during the earthquake loads, and particularly we are going to talk which is very famous theory called Reach and Matlock theory in lateral load on piles. Then we will consider dynamic analysis of piles where actual earthquake excitation or time varying load will be considered. After that we are going to talk about design for lateral and dynamic loads, and finally some codal provisions and numerical examples will be discussed. Today we are going to talk in the 2 lectures today and the next lecture. The first one, that is piles for static vertical load, and these are the contents for pile for static vertical loads. Introduction, what are the use of piles, types of piles, selection of pile type, we are going to talk about that. Then pile load capacity in compression, where this pile load capacity in compression can be found out using these 4 categories, either what is called static pile load formulae, pile load test, dynamic pile formulae, and correlation with penetration test data. So, today in the first lecture of this on pile foundation we are going to talk about that, and in the second lecture on pile foundation the remaining part here, that is group action of piles, settlement of a pile group, and some numerical examples, we are going to talk about that. So, let us have introduction. Particularly those the typically in civil engineers know that what is the use of the piles. You know that shallow foundation is usually provided when the soil at a shallow depth has adequate capacity to support the load of a superstructure. So, if the soil have adequate capacity and loads are not very heavy, then in that case we can go with the shallow foundations. However, when the soil conditions at shallow depth is poor, then in order to transmit the loads safely, the depth of foundation has to be increased till a suitable stratum is met, and such foundation is called deep foundations, where consist of piles, piers, and wells are the examples of deep foundations. So, piles and piers we are going to consider today in pile foundations, and well foundation will be the 4th module of this course. So, let us in the 3rd module pile foundations continue with that. When we talk about uses of piles, what are the typically when this normally the piles are small diameter shafts and they are used in the group. When we use well foundations, their diameters are more quite higher than for the pile foundations. Then when we talk about different types of how the different piles are used, accordingly we can categorize. First one is what is called end bearing or point bearing piles, where The load transfer mechanism is that the load, vertical load, is transferred through the end bearing action or point bearing action, and then this is that. But and this is most of the time when the pile foundation is situated on a hard strata or rock, then these types of piles are used. But there may be case when the piles are passing through the loose sand or soft clay, then you may not get the end bearing or point bearing action. Then what is called friction piles or floating piles are used through the soft soil or loose soil. Then third one category is laterally loaded piles, and that is important for us for earthquake resistant point of view, because it is the lateral load during the earthquake which is important than simply vertical load. So, laterally loaded piles are there, that is the third category. Then many times when you have that instead of vertical piles, many times piles are driven at angles, which is called battered piles, though nowadays the usage of battered piles is getting obsolete, because it is difficult to maintain the angle of inclination in battered piles. Then we have compaction piles, which are mostly used for compacting loose sand deposits, or you can say basically compaction piles are used for ground improvement. Here one need to understand that compaction piles most of the time do not carry the load themselves, rather their objective is mostly to improve the ground. Then you have the tension piles, which can use to resist uplift loads and thus are in tension. Then we have anchorage against horizontal pull, and that is called anchor piles. So, these are the like 7th categories. There could be many more, and these all are group has been done according to the usage of the pile and how the load transfer mechanism takes place. Then types of piles may be classified based on the material of construction. Normally piles are made of concrete, but there could be steel piles, there could be timber, and nowadays composite, that means a combination of the different materials, composite materials. So, depending on material of construction. Then depending on cross section also, it could be circular, square, hexagonal or I by H section. So, if circular section is there, square section is there, then accordingly the piles can be classified, the cross section of the piles. Methods of load transfer, it could be bearing or it could be friction. Then method of forming, precast, pre-stress, consensitive piles are there. Then methods of installation, either it could be driven piles or board piles. So, these are the different categories how the piles can be classified. Then now the question is that how we should select which type of pile we should use, what should be the material of the pile, what should be the load transfer mechanism. So, it depends on many factors, it is not only single factor. First factor is the type of structure and load it carries. So, what type of pile foundation should be used, that will depends on the structural load and what type of structure you have. Then location of the site, that means where it is good conditions and site conditions will also determine. Soil condition and position of water table is also one of the factor on which pile type will depends. Then required pile length and structural capability of the piles is also one of the issue. Then durability of the pile, for how long, what is the life of the pile required. Then finally economy also governed. For example, steel piles are expected to be expensive, and mostly steel piles are used only when the other you may not have a when concrete piles are not enough. So, these are the how we can select the type of pile. With this introduction, now let us talk about pile load capacity in compression. That means basically when the pile is subjected to vertical load only, there is no lateral load acting, then we want to find its capacity. So, in that case, first of all, before we find its capacity, let us talk about general requirements for satisfactory performance, and these general requirements are the same as for other two types of foundations. For any foundation, shallow foundation, pile foundation, well foundation, machine foundation, whatever type of foundation you may have, always you need to satisfy at least two criteria, basic criteria. One is that it should provide adequate safety factor against shear failure, number 1. Then settlement shall be within permissible limit. So, keeping in view these two criteria, we find out the capacity of the piles, and the load capacity of the pile for static loads or static vertical load can be estimated by several methods, and out of these they are mostly grouped into 4 categories. And this is, first is static pile load formulae, second is pile load test, third is dynamic pile formulae, fourth is correlation with penetration test data. All including dynamic pile formulae will give you the vertical capacity or pile load capacity in compression, not for lateral load or not for that. So, we continue with this, the load capacity for in compression. So, coming to the first one, that is static pile load formulae, then we will discuss pile load test and so on. So, let us talk about static pile load formulae. When a compression load Q is applied at the top of a pile, the pile will ends to move vertically downward surrounding the soil. So, pile is moving down, soil is there. So, naturally there is a that with respect to soil, pile will try to go down, and this will cause shear stress to develop between the soil and the surface of the shaft. That means, at the interface between the pile and soil, the stresses get developed and shear stresses, and load is distributed as a friction load along a certain length of pile from top. As the load increases, friction loads will be also increases. However, when the pile reaches to the at the desired location, and if you have a good conditions, particularly bedrock, then pile will transfer the load through the point bearing or end bearing action also. So, the total load, compressive load which pile can carry consists of two components, one is QF and another is QPU. QF is nothing but called ultimate skin friction resistance of the pile, while QPU is ultimate point load till the soil at the base falls by punching shear. So, if out of these two components of ultimate load, if QPU is quite higher compared to QF, then we call point bearing pile, and QPU is quite QF, if reverse is the case, then it will be called friction piles. So, if the major component of total load is carrying by point bearing action, then it will be point bearing pile. If major component of the total load is carried by the friction, then it will be treated as a friction piles. So, this is continue with this static pile load formulae, and let us how these pile load formulae have come into existence and what are the essence behind that, we are going to talk about that. As far as the point bearing action is concerned, the unit point bearing resistance QPU for a C-file soil may be determined from this equation, which is the ultimate bearing capacity equation, C N C plus sigma bar N Q plus 0.5 gamma B N gamma. Here one thing need to understand, that this equation is basically for shallow foundations, because here we can use this also for deep foundation or let us say pile foundation, but we need to simplify it for pile foundation. So, one need to understand that compared to width or diameter of the pile, length of the pile or depth of the pile is quite higher. Normally it is L by D ratio is more than 12, 15 or maybe 20, 40 like that. So, for the cylinder piles. So, in that case the term second term sigma bar equal to gamma into L, where gamma is the unit weight of the soil, will be quite higher than the last term gamma B N gamma. So, what you have, so the second term if you compare in this equation second term and third term, so this can be neglected, this third term can be neglected. Why? Because gamma B will be quite small compared to sigma. L is quite, length of pile is basically L is, if we compare, L is quite greater than B diameter, or B is the diameter of the pile or width of the pile. So, as a result this equation is simplified in this form QPU CNC plus sigma bar NQ. Here in this equation for a granular soil, QPU is will be given by sigma bar into NQ, while QPU for the clay soil C and C. Why? Because for the granular soil C will be 0 and for clay soil NQ will be 0 because phi equal to 0 or NQ particularly for the net bearing capacity 1. So, this for granular soil and clay soil QPU can be approximated from these equations. Now, one need to understand that sigma bar increases linearly and this though sigma bar is set as gamma L, that means if length of the pile is keep increasing, you go down and down, sigma bar will keep continuously increasing, but this is not the case. Rather, after a certain depth, this increase will become constant and that depth depends on the type of soil. So, the depth up to which it linearly increases and after that it becomes constant is called critical depth, and this critical depth is 15 times of diameter of the pile for loose sand and 20 times of diameter for of the piles for the dense sand. So, with this introduction we go ahead and we use QPU for further analysis. Now, let us talk about once you know the QPU into AB, where AB is nothing but the base area of cross section of the pile at the base, which is here, and the ultimate skin friction resistance can also be Fs average into As. So, this is base area at the area of the pile at the base, area of pile at the base, okay, while As is the surface area which will depends on the length also depth of the pile. So, here ultimate skin friction resistance is given by Fs average. So, we already discussed how to find QPU, AB and As. Now, let us discuss Fs average. Fs average is nothing but called average unit skin friction resistance, and for the sandy soil value of Fs average is given by this relation here, K sigma average tan delta, and with this relation let us work what is sigma average. Sigma average is average overburden pressure, that may be if it is constant, let us say gamma is constant throughout and then average overburden pressure will be gamma L, but it need to be up to the critical depth, after that it will be constant, and lateral earth pressure coefficient K and delta is angle of friction between pile and soil. The value of delta and K are listed in this table. So, you see that table depending on the pile material, delta is chosen here 20 degree for steel, for concrete 0.75 times of phi, where phi is the angle of internal friction. Naturally, this is applicable for sand only, as said, these all equations this table is for sand only. Then for timber 0.675, then value of K depends on what you have, whether loose sand or dense sand. For concrete, for loose sand K is 1, while for dense sand it is 2, and if it is let us say between loose to dense sand, then naturally you can go for the interpolation, for example medium sand is there. So, using the data given in this table and this formula Fs average K sigma average tan delta can be find out, and then we can work, but there are some limitations. After that there are some upper value of upper limit of Fs average which we are going to discuss, and the same thing is for QPU. What has been suggested that the limiting condition for Fs average is 100 kPa, that is 100 kilonewton per meter square for sandy soil. That means, from using this formula, the last formula, this formula, if you get the value of Fs average more than 100, then we need to use only 100 kilonewton per meter square, where for loose sand and sigma r increase up to 15d and 20d, which we already discussed. Then Fs equal to alpha into Cu for clay. So, when we talk about clay, this was the equation for sand. Now, for the clay the same equation get changed for the clay. For the clay simply Fs need to be found alpha multiplied by Cu, where alpha is adhesion factor, and the value of alpha depends on the Cu value itself, and depending on the Cu value alpha is can be found out from this chart. Here one need to understand that as the Cu increases, the value of alpha decreases. Typically for let us say 50 and around that, alpha is in the range of 1, or so you could see that in this graph alpha is varying from 0.5 to 1.4 or so. So, it is most of the middle if Cu is in middle range, medium range, then the value of alpha will be around 1. Then once you find out this so we are done with Fs. Now the issue is QPU. So QPU can be found out from this relation CNC plus sigma bar NQ, and if this relation is giving the value more than 11,000 kilonewton per this should be per meter is cube, this should be per meter square, kilonewton per meter, not cube. So if it is coming 11,000 kilonewton per meter square, then it should be used 11,000 kPa only for normal silica sand. Similarly, if it is more than 5,000 kPa for calcareous sand, then we will limit our values to 5,000 only. Then what you can have, the value of QU, total QU can be found out from this relation, that is ultimate load carrying capacity for a pile using static pile formula, QPU into AB plus Fs average into AS, where QPU are find out depending on type of soil using this equation, and Fs average is also depending on whether it is sand or clay, you can find out that. For pure clay, this equation turned Q equal to Cu NC AB plus alpha Cu AS. For pure sand, this is here. So what you have, this Fs average, and this will be simply gamma ln NQ. So using these two equations, you can find for ultimate bearing load carrying capacity or for sand or as well as for clay. So this was about static pile formula. The second part, to get the compression load, applied compression load, then that is called pile load test, that is in situ test. In situ means field test. So for getting the capacity of the pile, the tests are conducted in the field, and normally 3 types of tests are done. Vertical load test, which is to find the compressive capacity of the pile in compression, and the vertical load test yield what is called load settlement curve, and the analysis of load settlement curve will give you the vertical load test. Then second is called lateral load test, where you apply load as laterally and then find out the capacity there. Last one is pull out test, where you try to apply the tensile load and try to pull it out and then test it. There are two categories of test. One is called initial test, another is called routine test. Initial tests are conducted exclusively on the test piles, that means you need to construct a piles dedicated for testing purpose only. So and objective is to estimate the allowable load or predict the settlement at a working load, while routine test is carried out as a check on working piles and to access the displacement corresponding to the working load. So this routine test will be conducted at a working load, and we need to idealize to get the displacement and the capacity. So using this then let us discuss one of the typical pile load test, which is the total settlement. You could see that this in this graph, what is you could see that in this graph it is called load settlement curve, and in this load settlement curve you have load intensity here and settlement here. So the total settlement as consists of two parts, one is called elastic settlement and another is called plastic settlement. So the elastic settlement is that part of the settlement. Let us say you try to analyze this one cycle, here this is the up to this point, this is the total settlement from here to here. However, when the load is relieved, then this settlement is reduced to this value. So that means that this is the recovery, and this recovery is showing elastic settlement, while the remaining part is plastic settlement. So the total settlement at any load combination will be elastic and plastic settlement. Plastic settlement is that part of settlement which is not recovered even when the load is removed. Now we come to the what is called dynamic pile formulae. Dynamic pile formulae are useful in estimating pile capacity, and these are based on the laws governing the impact of elastic bodies. In dynamic pile formulae, what is done? A hammer is used. A hammer is dropped on the top of the pile to find its capacity, and there are 3 types of hammers normally used for this when dynamic pile formulae. One is called drop hammer, steep hammer and diesel hammer. In case of drop hammer, the hammer is lifted up and dropped freely, that means there is no force, it is dropped freely and lift it automatically whatever mechanism it have. So, no extra force is applied. But there are steam hammer, two types of, which is called single acting and double acting. In single acting hammer, what is done? Steam or air pressure is used to lift the ram up to the required height. So, what is done? With some force it is lifted, but when it reaches to the desired height, then it is dropped under gravity. No force is applied when it is falling down. So, that is the case for single acting hammer. While case of in double acting hammer, steam is used both sides, that means to lift the hammer as well as to drop the hammer. Then the third category is called diesel hammer, which are more popular because they are lighter and high mobility is there. So, that is used based on different now one of the dynamic pile formulae there is called engineering news formulae, and in case of engineering news formulae, the dynamic resistance of soil Q is assumed to be ultimate pile load capacity, and this is given by the relation W into H divided by factor S plus C, where Q is allowable load. Why it is allowable load? Because F is a factor of safety. So, whole this is divided by the factor of safety, and W is the weight of hammer falling through a height H. So, weight of the hammer is also known, from the height from where it is falling down, that is also known. So, the W and H is known. Factor of safety usually taken 6 in this case is also known. Then S is real set per blows and C is empirical factor allowable reduction in the theoretical side due to energy loss. So, you have this S plus C. So, using this like you can find the allowable load, where this H and S and C all three should be in the same units, okay, and the allowable load can be found in the units, which is unit used for the W. Then continue with this. So, engineering news formula, this formula which we have shown in this equation is derived separately for what is called drop hammers and for single acting steam hammers. For drop hammer, this equation is WS 6 divided by S plus 2.5, that means value of C is 2.5, while for single acting steam hammer the C value is 0.25 instead of 2.5. In both these equations, QA and W are in kilogram force, S and C, S, H and C are in centimeter. Okay. So, this was the story about engineering news formula. Then another formula came, which is for this which is also part of this what is called a dynamic formula, modified Hilly formula, and this modified Hilly formula is considered to be superior to the engineering news formula, as it takes into account the various energy losses during driving in a more realistic manner. And what is done here? Equating the available energy with useful work done and losses, then you get the allowable load. So, this equation gives you in this modified Hilly formula W H eta S plus half C1 plus C2 plus C3. What is the different notations in this case? Where R is ultimate driving resistance in tons. So, normally here this is used R here instead of QA, this is normally use R, and R is same as here because factor of safety is not used. So, it will be R, it will be not QA, sorry this misprinting in this slide. So, this is not QA, this will be R because no factor of safety is used below the equation. So, R is ultimate driving resistance in tons. The safe load is estimated by dividing the ultimate driving resistance by a factor of safety, that is 2.5. So, if we divide the value of R with a factor of safety 2.5, then you can get the allowable load QA. Now, in this equation as before, W is the weight of hammer in tons, H is effective fall of hammer in centimeter, and eta is efficiency of the blow that represent the ratio of energy after impact to the string energy of the ram. So, eta is the efficiency of the hammer. Now, what is C here? C is consists of three component, C1 plus C2 plus C3, and the S is the final set of penetration per blows in centimeter, while C is total elastic compression, which consists of C1 plus C2 plus C3. What is C1? Temporary elastic compression of dolly and packing, C2 temporary elastic compression of pile, C3 temporary elastic compression of soil. When W is greater than P and pile is driven into a penetrable ground, then eta efficiency is given from this relation, where if W is less than P, then and pile is driven into penetrable ground, then eta is given from this relation. In all these equations, what is P? P is the weight of the pile, anvil and followers, that means it includes the pile, anvil and followers. W is the weight of the hammer it was, and E was coefficient of restitution of the material under impact. So, E is dimensionless, there is no dimension of E. So, the eta, and this is ratio only, eta will be simply a ratio here in this case was on the second case also. So, this was what is we call modified Hilly formula. Now, the issue is this here, question arises, what is the usefulness of dynamic formulae for pile capacity? There, because of the uncertainty about the relationship between the static load and the dynamic load resistance, the pile driving formulae have very limited utility, because these are based on the assumption of impact of two free elastic bodies, while pile is not a free body. So, that is why this dynamic pile formulae they have limited applications. These formulas are useful for coarse sand, but are not so in the case of cohesive soil deposits. So, for the sandy soils they are better, but they will not give the good results when you talk about clay. In saturated uniform sand deposits, vibration during driving are likely to cause liquefactions. So, that is one of the factor also which need to be accounted, and the dynamic the formula fails to provide information about the settlement under the load. They will be able to give you the what is we call the allowable load or ultimate load resistance, but not the settlement. So, this is another limitation there, but for settlement best is you conduct pile load test, that is the best thing for finding the settlement. Now, the last category to get the vertical load carrying capacity of piles is called correlations with penetration test data, and the name itself when you see penetration test. So, you may be aware when we talk about penetration test, two of the most popular tests are SPT, that is standard penetration test, and another is called CPT, cone penetration test or SCPT. So, static cone penetration data, that is CPT, and standard penetration data SPT are often used to determine the pile load capacity, and CPT gives the variation of resistance value at tip of the cone, that is, and this value is called QC, sorry, this is not AC, this is QC, Q subscript C, and the skin friction resistance, okay, this should be skin friction resistance is basically this is QC and skin friction resistance is FS on the sleeve with the depth. SPT yields the n values of the subsoil strata at regular intervals of the depth. So, using these correlations with penetration test data, we can also find this what is the capacity. So, now we completed today in piles for static vertical loads, introduction, usage of piles, types of piles, selection of pile type, pile load capacity in compression, and now we are going to discuss in the next lecture these three topics: group action of piles, settlement of a pile group, and then numerical example also. Thank you very much for your kind attention. Thanks.